Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content.
Welcome to the world of electrochemistry, where we explore the fundamental physics that drive the clean energy revolution. Today, we'll delve into the principles of electron transfer in electrolyzers, paving the way for green hydrogen production. Atoms are the building blocks of matter, and understanding their structure is key to mastering electrochemistry. Electrons, with their negative charge, orbit the nucleus and determine chemical behavior. Remember, electrons can be removed or added, a process known as oxidation and reduction. Electric current is the flow of electric charge, driven by voltage, the potential difference. High potential means excess electrons, while low potential indicates a deficit. Understanding this flow is crucial for controlling reactions in electrochemical cells. Chemical reactions in electrochemistry involve electron transfer. Oxidation is the loss of electrons, while reduction is the gain. Remember oil rig. Oxidation is loss, reduction is gain. These reactions are fundamental to energy conversion processes. Electrochemistry bridges chemistry and electricity, focusing on electron transfer between species. It involves converting chemical energy into electrical energy and vice versa, as seen in galvanic and electrolytic cells. The electrochemical cell is where the magic happens. Electrons flow from the anode to the cathode through an external circuit, maintaining charge balance. This flow is essential for energy conversion in electrochemical processes. Thermodynamics sets the energy requirements for reactions. The standard cell potential is the minimum voltage needed, while Gibbs free energy indicates the work potential. Efficiency in water electrolysis is crucial for sustainable energy solutions. Kinetics tells us how fast reactions occur. The Butler-Volmer equation describes the rate of electrochemical reactions, influenced by parameters like current density and temperature. Understanding these factors is key to optimizing reaction rates. Explore the Butler-Volmer behavior interactively to see how overpotential affects current. Small changes in voltage can lead to significant current variations, highlighting the importance of precise control in electrochemical systems. Mass transport is crucial for getting reactants to the electrode. It involves diffusion, migration, and convection. The limiting current is the maximum current when transport limits the reaction, a key factor in electrochemical efficiency. Electrolysis splits water into hydrogen and oxygen. The anode reaction involves oxygen evolution, while the cathode reaction focuses on hydrogen production. Understanding these reactions is vital for efficient hydrogen generation. Different types of electrolyzers, like alkaline, PEM, and solid oxide, have unique characteristics. Each type has its advantages and challenges, influencing their application in hydrogen production. Where does the voltage go in an electrolyzer? The breakdown shows losses in various components, with the anode reaction being a major focus for efficiency improvements. Understanding these losses is key to optimizing performance. Current density affects performance trade-offs in electrochemical systems. High current density means compact equipment but lower efficiency, while low current density offers high efficiency but requires larger equipment. Balancing these factors is crucial. From fundamental principles to green hydrogen, the journey involves overcoming challenges like efficiency losses and developing better catalysts. The goal is to produce green hydrogen at a competitive cost with fossil fuels, driving a sustainable future.
Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated. It's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.